best tools you can. This one is a really nice chuck. Okay? I'm going to talk about your spindles in a little bit. Feel how smooth this works. That's a thread working together. That's what you want to do. That's a really good piece. We'll use that, or you can use that to drill your holes. Okay, parting line. Myself a mark. Myself a mark. Straight edge across it. Actually, some of that doesn't have any mark on it, so we'll proceed. Okay, I need to lay out 4 holes in a nice square pattern. The drawing tells us what that square is. How are we going to do it off of that line? Any bright ideas? Okay. Rob, I'm going to need a dial caliper. Can you grab one for me? Thank you.
I think we're going to use the dial caliper.
Yeah, we are. Good one. We are. That's a micrometer. This is a micrometer. What you'd like to know. We're going to use a dial caliper. You were testing me, weren't you, Rob?
No.
Sure you were. Okay. Checking my jaws, checking my zero. Our square on there is going to be 4.120 on the side. I've got a center line, half of 4.120. What is it? 2.060. If we're doing these questions in class, in a test, give me 3 decimal places. 060, 60 thousandths. Okay, that's what I've set that at. You're going to remember this stuff from geometry. This is why you took geometry, so you could come to my class and do it. Okay. Off of our center line, swing an arc. That same line, swing an arc. Over here, swing an arc. I'm going to swing another arc. What's that going to do for me? It's going to help me. Let's get there. Not quite a center point. Heck, I don't know how far apart these 2 arcs are. I don't really care. I can do without that. We'll see in just a second. Okay, 4 arcs. Anybody remember what a tangent is? You remember hearing tangents? Okay. If I drew a line 90 degrees to my center line, for example, coming toward me, right through the edge of that arc, tangent is 90 degrees to that line, or parallel with this line. So I'm laying out a tangent right now on both of those arcs. Back one. And that gives me 3 parallel lines. These 2 lines are now 4.120 away from each other. Now the next direction, locating the lines this way, is a little bit flying by the seat of your pants kind of thing. We're trying to measure off of a curved surface. And that's a bit of a hassle to do, at least in this case. So I'm going to take a mark here. I'm going to set this out to 4.120. Go one side of my box. That's the distance. And the guessing is how far it is from the edge here and here. And we can get it pretty close. And then we swing an arc on that one. We swing an arc on that one. And now we've got this distance set, and this set. The last thing to do is transfer those 2 points to the back. Pythagoras. All these wonderful memories of high school. Remember Pythagoras? What he teaches. So we did all this work. Yeah, b squared, a squared. A squared plus b squared equals c squared. All right? That means this side times itself plus this side times itself will give us our diagonal. Okay? You're in luck. You already did it. That'll be in your notes. We've got our 4.120. Our hypotenuse in this triangle is 5.826. Okay? So I set this out. 5.826. I can take that from the one corner I've got in the front, scribe that corner, take it from here, scribe that corner. Diagonals on a square, diagonals on a rectangle will be identical. And now I have my 4 points. Okay. We're ready to drill. We're almost through all this stuff. Remember we talked about a wiggler. A couple of you know what wigglers are. This is a wiggler. It's got a point on it. It's got a piece we catch in our pallet. And we want to true it up. We're going to use it to locate those holes so we can drill exactly where we want to drill. Just a little bit, tap it, comes right out. Like that one, and that one, yep. This will be the only time you turn on the mill and stick your hand in there where the tool is. Otherwise, you're just going to make hamburger. Get me all excited. Don't do that. Our wiggler to true it has a ball joint in there. Okay? So we get it close. Turn it on. It spins, but it doesn't spin true. We get in there, I tend to use my fingernail. We're going to true that up. Feel it running true. That now is a true reference to dead center on our spindle. I could shut it off, and I could use it just that way. But if I'm not paying attention and I bump it a little bit, it looks true, but it's not. Then I'd come over and line it up and drill a hole, and it's like, what? What happened? So I like to true it up while you're spinning. Can she bite you? Yeah, she can bite you. Now it's spinning pretty wide. Nice little sharp point in there. We like a sharp point. This is not a contact tool. Don't plow it into my work. I got wigglers over there that are pretty blunt because people try that. said, non-contact doesn't mean you can't get close. You want to get really close and see where your mark is. Then you can lock your table in your X and Y axis. I've got it where I want it. I can take that out, I can pull that nice Jacob's chuck in there, and I can drill my hole. Our instructions also have us reaming that hole. From now on, when you drill a hole, don't trust your drill to give you an accurate size. It tends to wobble a little bit, might not be evenly sharpened. So if you've got a 1/2 inch drill, say your hole is a 1/2 inch, probably plus a little more than that. If you need an accurate hole, you drill it undersized, and then you ream it to size. And ream, put something like a mill, no twist on it. It does a very fine cut, perfectly round, perfectly cylindrical. So we'll drill it, and ream it, and then move on. We do have the option for the other holes. We can go back to the wiggler and move it. In this case, I'm already lined up on both axes, but I can take this, come across this way with the other hole, tie it up, lock it, and I'm good to go. You also have the option, both of our tables, all 3 of our axes, have dials on them. 4.120 inches. I can set my dial at 0 and count my turns and move exactly according to the dial, 4.120 inches, and I'll end up right there. So you can learn how to use the dials here, or you can learn them later on. But you'll be able to use those, get it on 0, lock it, and go from there. Okay, we've got our casting figured out. We're working on sheet metal. We know where we're going with our base. I've talked long enough. I've talked far too long. Hope we're getting everybody busy. That's the goal.